to Impulse Mathematics. Today we talk about one more session about the conic section. So what do you mean by the conic section? That is, one fixed line is there, and this line I'm putting the name here, that is called L, and another one line is there, that is like that, making an angle with the fixed line, that is called alpha. And this line I'm putting the name, that is M. Now here M is called generating line, L is called here the fixed line, and M is here generating line. Now what is the purpose of doing these things? That is, if M rotate about a fixed line L, then a double napped cone will generate. That's why M is called a generating line. Here M will rotate about an angle alpha. With respect to this angle alpha, M will rotate. So what happened? What kind of figure it will generate? It will generate a double napped cone. So how the double napped cone look like? That is like this. So double napped cone will be look like this. Like that. Okay. So it will call the double napped cone. Now here one fixed line is there with it. That line is called this one. That is L. This L line is called the double nap cone. Okay, here M, this line is called M, and after making the angle alpha, this line will be here only. So this generates a double nap cone. Now this fixed line is called axis. This fixed line is called axis. Okay, now what happened? If one plane is there, one plane cut this double napped cone. Now one plane, what happened? That one plane will cut this double napped cone. Okay, so then what happened? We'll take this and like this only. I'll change the color here. So it just look like that. Okay, this cone cut the double napped cone by that, and with a certain angle, we can say like this. Here the angle makes this. With respect to this axis, it will make the beta angle. Here the angle is 90 degree obviously, so it will make a circle. It will make a circular path like this. Okay. Now if it is bend, this angle beta is not equals to 90 degree, or the angle beta is here, that is less than 90. So what happened? There is a it will generate a ellipse, and if the angle alpha is equal to angle beta, then it will generate a parabola. And if it is the angle beta is less than alpha, that means alpha is greater than beta, then it will generate a hyperbola. So there is 4 cases will be there. If the alpha less beta and this is equals to 90 degree, if beta equals to 90 degree, then it will generate a circle. So this point it has to be remembered, like number 2. If alpha equals to beta, that means this angle equals to beta, then it will generate a parabola. Okay. If alpha less beta less 90 degree, it will generate a ellipse. Okay. If 0 less equals to beta less than alpha, that means here alpha greater than beta, that time it will generate a hyperbola. Okay. One cone we have and one plane. So a plane cuts the double napped cone in an angle beta, so there will be these 4 possibilities. Okay. I hope it is clear to you. Now next we'll talk about the parabola. So what is parabola? The definition of parabola: this is the path. A parabola is a path that traced out by the point which moves in a plane in such a way that the distance from a fixed point is always equal to the distance from the fixed line. So here in the circle we talk about one point, and the one point is moving and one fixed point is there, and the distance is always same, that type of thing. Here one line and one point will be there. One fixed line and one point will be there. Suppose we have the coordinate axis like this. Okay, I'm changing the color here. We have the coordinate axis like this, and one graph we have like this. Okay, so this is actually a parabola, and one fixed line is there. That line is this one. One fixed line is there. Okay, now what happened? That one fixed point is this. This fixed point is called the focus, and we named it F. This fixed point is called F, and that is called focus. And this is the fixed line that is called DD dash. and this D is actually, this is our coordinate axis, definitely. That is x test, y test, and we take that this vertex of the parabola is at 0 0, that means the origin. Okay, so what happened, this is the fixed line, d dash is a fixed line, d dash is a fixed line, and here f is fixed point. So this thing you must remember, that d dash, this line is fixed, this point is fixed. Now that any point you take on this parabola, any point if we take in the parabola, that is suppose this one pxy, this point will taking. Now what happened, that the distance between these two, this pf, distance between this pf and this one, that means the perpendicular distance, we must take the perpendicular distance between this one. These two distance must be same. If I put the name here m, so what happened, that must be the perpendicular distance, that means this is 90 degree. So here pm must equals to pf. Now if this thing happen, then the locus of this point P is actually called the parabola. Locus of the point P is actually called the parabola. Now we need to define the equation of the parabola. This is general equation of the parabola. So first of all we make, so let us see that how we can generate the equation of parabola. Now again I'm going to draw the figure. So here it is. Now you can see here that we'll take this f point as, we'll see the f point as a0. That means the focus f is at a0 because it is lies on the x-axis now. So the y coordinate, definitely the ordinate will be 0. So the f having the coordinate a0 and p having the coordinate xy. So definitely these two distance also same, isn't it? That these two distance always also same. This. So the coordinate of this point will definitely minus a0, right? So what will be the equation of this one? What will be the equation of d dash? That is parallel to y-axis. So parallel to y-axis means the equation will be x plus a equals to 0. Okay. Now distance form pxy will be, now one line and one point, the distance between one line and one point, that is defined by mod of x plus a divided by root under of 1 square plus 0 square. So definitely x plus a, right? So distance, this is the formula of distance from the point and the line, dt dash, this one. So again we need to define the distance of pf. So pf distance is defined by, that is root under of x minus a whole square plus y minus 0 whole square. Now what happened, that is we know that the path is stressed out by this one. The condition is pm equals to pf. The condition is pm equals to pf. So with regarding this condition, what happened, that is we can say pm square equals to pf square. So pm square is nothing but, this one is pm, no, this one defined pm, as this is the distance from the fixed point to the point pxy, that is a fixed line dt dash and the point pxy, that is distance pm. So pm square equals to pf square. Here this one will be x plus a whole square, and pf square will defined by x minus a whole square plus y minus 0 whole square. Okay. If I define, it will be x square plus 2ax plus a square, and this is equals to minus 2x plus a square plus y square. So this a square definitely cancel out, and here also this x square will cancel out. So we'll have the y square equals to 4ax, and this generates the equation of general equation of parabola. This define the general equation of parabola. Okay. Similarly, if the figure is look like this, that is this one, no. So what happened? Same thing, there will be a line, fixed line, and there will be the fixed point. There will be one fixed point here. That point is f, and this point, this is d dash. So this f having the coordinate, what kind of coordinate will be? There is 0 a. So this having the coordinate 0 minus a, right? And here is our point, that is 0 0, because this is our axis, right? X y. Now one fix the distance between these two fixed point will be same, like that. Like if I take the pxy here, so this distance and this distance must be same, right? It doesn't look same, but in mathematically it's same, where this angle must be 90 degree. Okay, so this is the pxy. Okay, after calculating this one, we'll get this equation as y square equals to, sorry, x square equals to 4ay. Okay, so this will define the equation of the parabola, where the axis, here the directrix, this dd dash is called the directrix. Here f point, this f is called the focus. F is called focus, and this dd dash, the fixed line, is called directrix. Okay, now we'll move to another thing, that is, this is our figure here. Now this one line may be there. I'm taking one line here, which is move like this. Okay, now this line is called latus rectum. This line is called latus rectum. What is the coordinate of this one? That is a0, right? So now the general equation is y square equals to 4ax. This is the general equation, isn't it? Now after this one, let us take, but what will be the coordinate of this? What will be the coordinate of this point? That is called L, and this point is called L dashed. Now what will be the coordinate of L? We'll take that coordinate of L will be like this. That is, if this point is a0, so definitely the coordinate will be a small l, and this having the coordinate a minus l, right? Because these two distance definitely same. So, and these two point L dash, L and L dash lies on the parabola. So what happened? That L dash definitely satisfies this equation. L dash will satisfies this equation. So definitely it will be L square equals to 4a into a. So L square equals to 4a square, or we can say L equals to 2a. So definitely these two points have the coordinate a to a, or here a minus 2a. So what will be the length of L dash? L dash will be length of 2a plus 2a, that is called 4a. So the length of the latus rectum in the equation of the parabola y square equals to 4ax, that is 4a. Length is here 4a, where a0 is the coordinate of the focus. Okay, like this we need to take the equation of the parabola. Now similar kind of 4 kinds of parabolas are there. We can define this one by the one chart is there. There is this one. With regarding this chart, we can find the 4 kinds of parabola. That is this, first of all, the right-handed y square equals to 4x where a greater than 0, that is called right-handed parabola, and y square equals to minus 4x where a greater than 0, that is left-handed, and x square equals to 4ay, that is upward, and x square equals to 4ay minus 4ay, that is downward. Okay, so this kind of 4 kinds of parabolas are there. Okay, where this focus is given, where a0 minus a0, 0 minus a, and this one, vertex is there, equation of directrix is there, equation of axis is there, length of latus rectum is there, equation of latus rectum is there. Okay, so with regarding this, we can define the parabola. Now next, one more important thing is there, that is called parametric equation. Parametric equation of parabola. So the general equation we always take, that y square equals to 4x. With regarding this, we define the parametric equation, that is called, now parametric equation is defined equals, that is x equals to at square and y equals to 2at, where t is the parameter. Now if I eliminate t here from these two, we'll get this equation. How can we see this one? That where from this we can generate that t equals to y by 2a, right? And from this we can say that t square equals to x by a. Now after eliminating this one, we can say that y by 2a, that whole square, that must equals to x square by x by a. or y square by 4a, this is equals to x by a, or y square equals to x by a into 4a. So a will cancel out, sorry, this one 4a square, so this thing will happen, that is 4ax. So y square equals to 4x will get. This is how we can say that this is the parametric equation of parabola. So very important thing, that parametric equation of parabola is x equals to 80 square, y equals to 280. So the point if we take on the parabola, so we consider this one as 80 square 280, like that. If we take one coordinate in above the parabola, that will take like this, that is 80 square 280. With this note we conclude here. In the next session we'll talk about some more regarding the parabola.